Hello everybody, in this video I will help you with your final exam preparation. I will discuss the 2024 Gauteng Prelim Paper 2 Question 9. 9.1. In the diagram below, O is the midpoint of the circle. Points S, T and R lies on the circle. QS is a tangent to the circle at S. Use the diagram to prove that the angle between the tangent and a chord is equal to the angle in the opposite segment. In other words, we need to prove that angle QST, this one, the angle between the tangent and the chord, is equal to angle R. Now for this very important proof, we need a construction. So we will draw in a draw diameter SK. I'll add the K now and join KR, and there's your K. Now here's the proof. We can start by saying that angle QSK, which is this angle there, that one is 90 degrees, and the reason, radius perpendicular to the tangent. Furthermore, we can say that angle SRK, which is this angle, is also 90 degrees, but the reason is angle in semicircle since O was the midpoint. Then we can say that but angle TSK, which is that angle over there, is equal to angle TRK, this tiny little angle there. And the reason is angles in same segment. Therefore, we have that angle QST is equal to R. 9.2. In the diagram, D, E and F are points on the circle with center Q. AGF is a tangent to the circle at F. ED is produced to meet the tangent at A. B and C are points on AE such that GB is parallel to FD. That is indicated on the sketch. GC is joined. GDCF is a cyclic quadrilateral, and FQD is equal to 2x. That FQD, that's the angle at the center. Now the question says, number 1, give a reason why angle E is equal to x. And I think you know why. The reason is angle E is equal to x. The angle at center is equal to twice the angle at the circumference. Number 2, we need to prove that GC, this one, is parallel to FE, which is that one. So let's see. We can start by saying that angle F1 is equal to E is equal to x. Now why? Remember in the previous one we decided that E was x. So F1 is the angle between the tangent and the chord is equal to the angle in the opposite segment. Then, can you remember this theorem where C1 is equal to F1? Now, why can I say that? So, I can say that it's equal to x because F1 is equal to x. But what's your reason? That one is the exterior angle of a cyclic quad, because right at the beginning they told us that GFDC is a cyclic quad and C1 is the exterior angle of the cyclic quad. Now we can see that both these statements have F1 in common. So therefore we can say that C1 is equal to E. So we have that C1 is equal to E. And can you see they, in fact, are corresponding angles equal? And that implies that GC is parallel to FE. What's our reason? Corresponding angles equal. Number 3, we need to prove that the ratio AB over BD is equal to AC over CE. Now just remember from the previous sum, we decided that GC was parallel to FE. Now, because there's parallel lines and there's triangles, we can use the proportionality theorem. So we can start by saying that AB, there's AB over BD is equal to AG over GF, the proportionality theorem, since GB is parallel to FD. Then, remember there's other parallel lines as well. So we can also say that AG over GF is equal to AC over CE. That's also the proportionality theorem, since GC is parallel to FE. Then you will see that AG over GF, this one, is common to both. So then, therefore, we can say, and that's what they wanted, AB over BD is equal to AC over CE. Number 4. It is further given that AB is equal to 12 units, CE is 22,5 units, and 5AG is equal to 4GF. Determine the length of CD. Now, in the green there on the left-hand side, that's the answers from the previous sum, so because we're going to use that. Now, we can start with this part that's given. This 5AG is equal to 4GF. So what I can do is I can divide GF away and I can divide 5 away. And then I end with a ratio AG over GF is equal to 4 over 5. But, are you with me? AB over BD is equal to AG over GF. So here we said AG over GF is 4 over 5. So now we can say AB over BD is equal to 4 over 5. And it was given that AB was 12. So 12 over BD is equal to 4 over 5. Then let's solve BD. So let's swap those two around so that BD is the numerator on top. BD over 12 is equal to 5 over 4. And we solve BD and we end with 15. Then, furthermore, we can also say AC over CE. Now, it's this one. AC over CE is also 4 over 5, since AC over CE on the left-hand side is equal to AG over GF. There you can see. And we know that AG over GF is 4 over 5. Then we can say right here CE is equal to 22,5. So in CE's place we substitute 22,5. We solve AC and we get AC is equal to 18. But they want CD. So let's see. Do you agree? BC is equal to AC, the whole of AC. Let me show you here. BC is equal to AC minus AB. And AC is 18 minus, and AB is 12. So 18 minus 12 is 6. And then lastly, let me change the color here. DC. There's DC is BD, which is this one, minus BC, that little part there. So BD was 15 and BC we just calculated was 6. 15 minus 6, the answer 9. Thank you for watching my video. If you click on the video in the left hand corner, it will take you straight to the next video, the question 10 of this paper. And then on the right hand side, you will see I added the 2 playlists on grade 11 Euclidean geometry as well as grade 12 Euclidean geometry.